We're going to do a little more work with the Pythagorean identity. Previously, we derived where this relationship comes from. Sine squared theta plus cosine squared theta equals 1. And as the name implies, this does come directly from the Pythagoras theorem, a squared plus b squared equals c squared. So we're going to look at this, and there's a couple other things that can come readily out of this relationship. Now I just want to mention that this here is one of the fundamental relationships when it comes to trigonometry. And trigonometry is the math of sine, cosine, and tangent in those functions. So this is used quite a bit, but let's take a look at another use of this. So backing up a little bit, we started with a right triangle like that, and we said this side up here is 1, and we're going to use this bottom angle down here. We're going to call this theta, and for sake of simplicity, we're going to call this length here x, and this one y, and then we can go ahead and do our sine and cosine. So sine theta is opposite over hypotenuse, which is y. And then cosine theta, adjacent over hypotenuse, is x. Now I wrote them on the sides here because this side here, which equals y, is just sine theta. And this side over here, which is x, is cosine theta. So keep that in mind. Now we've done the two sine, cosine parts. Now we're going to look at tangent. Okay. Tangent theta is opposite over adjacent. Theta, this is opposite, this is adjacent, so I'm going to call this y over x, or sine theta over cosine theta. So we just derived another relationship here, and it says tangent theta is sine theta over cosine theta. And let's go ahead and use this as an example to show how this would work out. So let's say I have a triangle. And we'll make this a 30, 60, 90 right triangle. And the side ratios are the short side, which is over here. This is going to be a length of 1. The hypotenuse is the longest, a length of 2. And then the middle length here, opposite this, is root 3. Now, we're going to go off of this 30 angle right here, okay? We're going to use this angle. So we know from previously that tangent of 30, we'll just use this triangle, is opposite over adjacent, which is 1 over square root of 3. We have to rationalize the denominator, so multiply it by root 3 over root 3, which is root 3 over 3. So tangent of 30 is root 3 over 3. However, we also know that tangent can be calculated sine over cosine. So let's go ahead and figure out the sine going to be tangent 30 sine 30 over cosine 30. So sine of 30 is opposite over hypotenuse. This is going to be 1/2 over adjacent over hypotenuse. Now we can go ahead and simplify this. So to simplify a fraction over a fraction, we're going to take the bottom, we're going to rotate it, flip it like that, and multiply it. So this is going to be then 1/2 times 2 over square root of 3. And we just multiply right across, and we get 2 over 2 root 3. 2 divided by 2, that simplifies to 1. We get 1 over the square root of 3, which is the same value right here. Then rationalize the denominator, and I get root 3 over 3. You'll see that that one and that value, calculated through different ways, both give me the same answer. Now, the reason this is a big deal is there will be situations where you are given maybe the sine of an angle and need to calculate the cosine, or you're given the cosine and you need to calculate the tangent. You will see, you'll be able to take any one of the relationships and calculate any of the other relationships. And that's a pretty valuable thing to be able to do. Okay, so let's try one of those, for example. Let me erase this a little bit. How about this one? Sine theta is 1/4. Cosine theta equals, and tangent theta equals. So given the sine of theta is 1/4, what is the cosine of theta and the tangent of theta? So I'm going to go back to this relationship here. And we'll go ahead and substitute. So we have 1/4 squared plus cosine squared theta equals 1. So 1/4 squared is a 16th. So cosine squared theta is 1 minus 1 over 16. Not there yet. I'm going to take it up to here. I'm just going to do this bottom part right here. So we have cosine squared theta equals 16 over 16 minus 1 over 16 equals 15 over 16. Now we're not done yet. This is cosine, and this is cosine squared. So we need to take the square root of both sides. Cosine theta is going to be root 15 over 4. Okay? So cosine theta is root 15 over 4. So we got 1 down, so we got this one. Now we need to do tangent theta. Tangent theta we'll do like we did a minute ago. I got enough space over here. Tangent theta, sine theta over cosine theta. Sine theta is 1/4. 1/4 divided by root 15 over 4. which is 1/4 times, and we're going to flip it. So it's 4 over square root of 15, which, let's see, 4 divided by 4 simplifies to 1. So it's 1 over the square root of 15. We have to rationalize that. We can't leave a rational number in the denominator. And that's going to be root 15 over 15. That right there is the tangent of that angle. Now, you might ask me, hey Matt, why did you simplify the square root of 15? Let's take a look at that for a quick second. Now, the answer is, I can't. It's already simplified as much as possible. Okay? But let's take a look at that one. So when you simplify a square root like this, factor it down. See, 15 is 5 times 3. I'm done. 5 is a prime number, 3 is a prime number. Neither of these are a perfect square, so I can't take them out of the square root. So square root of 15 is the exact number. This is what you want to leave as an answer. Do not use your calculator. However, if you got to run to the hardware store and your calculations show you need root 15 over 15 board feet of lumber, don't go up to the clerk and ask for this much lumber. It'll kind of look at you funny. Use your calculator. But as long as we're in a math class or physics or science, stick with this as long as you can. Because you might find out later it simplifies out or disappears somehow. So don't remove that root.